Notes is that I need you guys to write down these steps. These are the steps that we use to evaluate with the calculator. So there should be relatively 7 blanks at the top of your page. In those 7 blanks, you should be able to write these rules. The reason why I had to put this in here because the original rules were to do it on a TI-84. But we do not use TI-84s anymore, so we have to write the NSPIRE rules. So the NSPIRE rules are: 1, open a new graph page. 2, graph the left side of the inequality. 3, press the tab button and graph the right side of the inequality. 4, find the intersection. You find the intersection by pressing menu 6 forward. It's going to come up lower bound. Lower bound means go to the left side of the point and click. Upper bound means move to the right side of the point and click. And then you'll have your intersection. And then the final step is use the x value only to determine when the inequality is true. Sometimes you might need to use the table. So I'm going to give you a moment to write that down.
Or a lot of them.
I could have, but you memorize things better when you write it yourself.
When I'm writing stuff like this, I don't pay attention.
Yeah.
When I'm reading.
That's why I'm not going to talk. I've already read it once to you, so now you get to write it and then read it to yourself.
Nick, you feel like a man.
You don't know how to read and
You feel
write.
like a man. What's your word?
Touch me.
Are you done writing it?
No.
Okay. Mark, are you done writing?
No.
Okay, then stop talking.
I'm sorry, man.
Are you recording today?
Yes.
Just look it up on YouTube. See if it's me.
They can hear you.
Hopefully I left you enough space.
Yeah. Yes, you did. Not for long.
Yes, you did.
Oh my gosh.
It should be roughly 7 lines, and I think I only wrote 7 lines.
You done?
If you're done at this moment, I would like you to practice the steps using the practice problem at the top of your page. It says 3x minus 7 is greater than or equal to 1/2 x plus 3. So I would like you to practice that problem. If you're done writing the notes, follow the steps.
So when you first graph the left side, you just press tab 2, right? You press tab.
Wait. I'm confused after number 4.
Okay. Is everyone done writing?
No. So, I need a little bit.
All right. So what we're going to do is follow what it said. So I'm going to open my window. I either can hit new document or I can click on this blue graph symbol. It starts a new graph page for me. I'm going to put in step 1 says open a new graph page. I did. Step 2 put in the left side of the inequality. So my left side says 3x minus 7.
Where you at?
Well,
Wait, mine doesn't say that.
I said the practice problem at the top of the page.
Oh, I didn't use the print.
Oh. True.
3x minus 7.
So I put in 3x minus 7. Then I'm going to press tab and I'm going to put in the right side of the inequality, and it says 1/2 x plus 3.
Can you just do like
0.5.
it's not the parentheses like 1 divided by 2?
Okay? So notice that the red represents the right side and the blue represents the left side. Okay? So, now we got to find the point of intersection. So to find the point of intersection, what does my instructions tell me to do?
To go to the right.
Press menu,
Menu,
6-4.
6, 4. So I start on the left of the point and I click. Then I go to the right of the point and I click. And there's my point of intersection.
Oh yeah, my graph don't look like that.
Oh, wait.
But
How do you know to click 6 and 4?
Go back.
It tells you to.
I didn't click 6 and 4.
Right.
Oh, because it says
But what if it's on the left side? Do you still click?
menu 6-4 takes you to the intersection.
Oh,
Why does
okay,
mine
okay.
look different?
Mine looks nowhere near
You're missing a function, so you skip step 2. No, step 3. So you press tab and graph the right side. You press tab and graph the right side of the inequality.
Oh, I got them all here.
Yes.
Do I click the left or the right side? I'm gonna click the left side first.
Press menu. 6.
Why is
Four.
it asking me?
Left. It says go to the left of the point and click. Go to the right of the point and click.
You click the left first.
Oh, so it says no running from the left to the right.
You see the point of intersection, right?
Because I had to get to the left of the point.
Oh, so I have to go right here.
Yeah.
Yes,
And
to
then you
the
scroll
left
over
of
and
the
go
point.
to the right.
I just moved it so you could see the values.
And then when it says the upward bound.
Then you go to the right of the point.
Oh, you gotta go up it.
All right, so which value do we utilize?
Wait. 4.
X.
We use the x, and what is x?
4.
4. Menu,
I'm not gonna
6, 4. Go to the left and click.
I just click anywhere?
Click, then up or down, left,
See that?
look, menu, 6, 4. I'm gonna go to the lower bound, means left, upper bound, means right.
That was your side?
Yeah. All right, so I have this, and now I'm going to focus on the x. And what is the x?
4.
4. So I have x is 4. Now, what I need to determine is, at this point, I want 3x minus 7 to be greater than or equal to 1/2 x plus 3. Okay? If I want it to be greater than or equal to, I know that this symbol has to be greater than or equal to or less than or equal to symbol. So at 4, I'm looking here. When is this function greater than this function? Is it when my x values get bigger, or is it when my x values get smaller?
Bigger.
When my x values get bigger. So it's when x is greater than or equal to 4. And that would be the solution to this problem. Okay, so we're going to look at it at the table point of view. So we said it's when x is greater than or equal to 4. So let's look at it as a table. So if I hit,
You get that X is greater than 4.
I'm going to. So if I hit Control T and I look at the table, notice here at this point they're the same value, right? When x equals 4, they are the same value. I want to know, when does the blue function start getting larger than the red function? Well, if I'm less than 4, what happens? Is that true? If I'm less than 4, I get what then, the number?
You get smaller.
I get smaller. But if I'm greater than 4, what starts happening?
You get bigger.
I'm getting bigger than the red value.
How do you pull up a table?
Control T.
Wait.
Okay? So again, we identified 4. 4, our independent variable, tells us what our factor is. Because does our dependent variable determine what happens? No, the independent variable determines what happens. So when x is 4, they are equal to each other, right?
Yes.
And the problem says, when are they equal to each other? And when is this function, 3x minus 7, greater than 1/2 x plus 3? Well, it's after 4, right? So any point after 4 is greater than any point after 4 of the other function. 14 is greater than 6.5. 11 is greater than 6. 8 is greater than 17 is greater than 7. Okay, that is all it's wanting you to illustrate and explain. At what point is it greater than? Okay, what are your questions?
So it'll be like x is greater than or equal to 4.
So the answer will be x is greater than or equal to 4.
Or can it be less than if it's going down, right?
It would have been less than if it said, when is it less than? When is this function less than 1/2 x plus 3? But the question wasn't, the problem wasn't when was it less than, the problem was when is it.
Where's that question at? Oh, the thing. Okay.
The
now I got it.
inequality.
Sorry. Yeah, I got it.
So let's see if I can get it into focus.
This Jones. I put it in the same way you did, but it looks different. I think.
Because you did not put it in the same way I did?
I did.
You changed your window.
Oh, what?
Your window?
Oh, I didn't think I did. I don't know.
Alright, so notice here, the problem is saying when it's such that this is true, when would this be true? This would have to be true at 4, and any number greater than 4, this statement is true.
Did you just plug in 4 to x?
If you plug into 4, it's just going to validate that they are equal to each other. You're going to get 5 on this side, and you're going to get 5 on this side, right?
Yeah.
That's the point that they prove that they're equal to. Now you need to prove when they are greater than. So are they greater than when I get larger than 4, or are they greater than when I get smaller than 4? Larger. So any number past 4 is going to make this inequality true. Your goal is to make the inequality true. And any number greater than 4 or equal to 4 will make this inequality true. Alright? Okay, so we're going to go back to our problem. And we're going to do number 1. On number 1 on my paper, excuse the fact that it's a little questionable.
There's no lines in there.
I have no lines.
2x plus 17 is less than equal to negative 4x.
There we go. There are my lines. They're back. What I want you to do is, where's this inequality? We're going to cross out the inequality, cross out the y3. The reason why we're crossing out the y3 is because this is when it pertained to using in 84.
And what?
When you use the older calculator, the 84s, that's why that matters.
Wait, Miss Brooks has the order calculator, right?
She just has the non-color INSPIRE. Alright, the left side of my function is,
2x plus 17.
so that's what I'm going to graph first, right?
Yes.
The right side of my function is
Negative 4x
minus
minus 16.
16. And what am I looking for?
You're looking for the intersection.
So I need to know when they are,
Intersected.
when y1 equals y2, and I also need to know what?
X2
When y2 is what, then y1?
Less than or equal to?
less than
Y2 is this one, so y2 needs to be what?
greater.
Greater than. So I'm also looking for when y2 is greater than y1. So when I graph, I need to see an intersection, and I need to see when this function is above or growing faster than this function.
It doesn't need to have the equal to sign?
No, because I wrote them separately. If I had written it together, but I wrote it separately. Then you put the little and symbol. And. Okay, so the intersection represents the equal point, and then the greater than symbol represents when is it above it. Huh?
We need to put that at the bottom.
Yeah, so that's what we're crossing out.
I don't know what that means.
The and? Just write the word and.
No. Well, why do you put that?
This is my and symbol.
No. Why do you put that at the bottom? Like when y1 equals y2.
So that when we look, we're trying to make this inequality true. So when we visually look, we're trying to see when y1 equals y2. That's their point of intersection. And then we're also trying to see when is y2 greater than y1. So when is this function greater than this function? And that's what we're trying to see when we graph. So I'm going to graph. I'm going to go back here. I'm just going to press home and get a new graph. Notice how it says F3 and F4. That just means those my y1 and my y2 just have different names. All right, so I'm going to put in 2x plus 17. And what do I get? This beautiful line.
I press enter.
I'm going to press tab, and I'm going to put in the right side of the function. And the right side is negative 4x minus 16. And I press enter. How do I find the point of intersection?
Menu 1, 6, 4.
Menu
6, 4.
6, 4. Lower bound means I go to the what side of the point?
Left.
Left. Lower bound means I go to the left of the point. Upper bound means I go to the
Right.
right. So where is my intersection?
At negative 5.56.
At negative 5.56. So which variable is the most important? Which value? The x. So therefore, do I really care what 6 is? No, I care about negative 5.5. So here you can sketch.
Do we have to?
It's a sketch. So I'm going to go roughly negative 5. Right? So I know that y1 was this way. Somewhere, right?
Yes.
And y2 was
The other way.
the other way. I don't know what the intersection was.
It was 4.
Was it
Negative.
4?
Yes.
Okay. Close enough. All right. So this is my y1. This is my y2.
The solution is the answer, right?
So the solution is the answer. I know it's about x, and I know that.
Less than or equal to negative 5.5, right?
So we just got to figure that out. When is this function, when is y2
Control.
greater than y1? If I can't visually see, what should I do?
Control T.
Control T and look at my table.
I thought it's the same thing as what's in the.
Not always. We just want to verify that it is. All right, so I'm going to go to negative 5.5. We're close to it, right? So at negative 5, they're clearly not equal. Well, let's look at negative 6.
It gets less.
Is y2 greater?
Yes.
Is y2 greater?
Yes.
No.
Yes. Is it 12 greater than 3?
Alright, I'm
Yes.
tripping.
You mean 8
Is
greater
it
than
6?
5?
Oh, I just jumped up one. Is it 8 greater than 5?
Yes.
Is it 12 greater than 3?
Yes.
Is it 16 greater than 1?
Yes.
So when is this true? When my x values are what than negative 5.5?
Less than.
Less than or equal to negative 5.5.
So when would it not be the same?
When you go the other direction.
Oh, so you just look at the Y's and then see what the X is.
Which one?
So Heaven, I love that you're always trying to find a pattern. I love it. The reason why this may not always be true is because if I have to divide by a negative, what is it going to cause it's going to cause it to change. So it cannot always be true because there's a chance that my function divided by a negative.
But won't you see it?
Huh?
Oh, we don't. Okay, never mind. I got it.
You got it? Now, was that so bad?
I just don't get how to get the solution.
Okay. Well, you get most of your solution from finding the intersection, right? Yes? Okay. And then once you're at your intersection, you can look at the table and see at that point of intersection what happens. If I go up, well, if I go up, that means I'm going less than, right? So if my x values get smaller, what happens? Is what happened is what I want it to happen, then that's what I'm going to use. If I go down, which means my x values are getting larger, am I getting my desired answer? All right. We're going to do number 2 together, and then I'm going to leave you to do number 3. All right. Are we ready for number 2? So what's my left side? Because mine is all.
1.6x minus 2.2.
All right. So it's 1.6x minus
2.2.
2.2.
Yes.
What's my right side?
4.8x plus 7.4.
Okay. So what are we essentially looking for when they are?
Intersected.
When they intersect?
Y1 equals y2.
And
when y1 is
Less than
or equal to y2.
well, we already handled the equal part here.
I put it though.
If you put it the other way, like y2 is greater than y1, that's fine. They're interchangeable. All right, so let's follow the steps. I'm just going to go home, get a new graph, and I'm going to put it in. So 1.6x plus, oh, is it minus? I'm sorry. Minus 2.2. There's one of them. Press tab. I'm going to do 4.8x plus 7.4.
Is there ever going to be a time when we start on the right when we're trying to find the intersection?
Lower bound means left. All right, what do y'all notice? Could you see the intersection? No. The way you're able to see the intersection is if you go to any any blank white area, hold down the center of your mouse and pull it up. Or pull it so that you can see it. So now you should be able to.
I just read 6.4 and I did it like that.
It'll still find it.
It'll just go.
It'll still find it. All right. So menu 6, 4. Lower bound means I go to the left. Upper bound means I go to the right. And so where's my intersection? So I know my solution involves which value? Negative 3. So let me sketch my little graph. I think I'm gonna cheat a little, guys, because I don't feel like sketching. Sorry. Whoa. Didn't expect that to be that ginormous. Oh, there we go. Perfect. I knew I could do it. All right. There's my sketch. It's all Baylorified and everything.
Straight lines.
I made straight lines, right. All right, so I know that my answer is going to be x and negative 3, right?
Yes.
All right, let's look at it. So we want to know when they're equal. We got the equal part. Let's put our equal. Now we want to know when is which function? y1 less than y2. So for me, it's my green value. When is my green less than my yellow? Is it when x's are getting larger, or is it when x's are getting smaller?
When they're getting larger.
When it's getting larger, so it's when x is greater than or equal to negative 3. And if I wanted to check, what do I look at? I verify with my table. So I go to my table, I hit Control T. Alright, so at -3, I want to see, they're the same value, right? -3, perfect. So now I want to know, when does my green value start getting smaller than my yellow value? Well, at -2, what happens? It instantly got smaller, right? And it's still getting smaller, still getting smaller, still getting smaller. As these values are getting smaller, what is my x value doing?
It's
Getting larger.
It's getting larger. So we use a, what symbol? Greater than. So it's greater than. It's when it's greater than -3. And there you go. All right, before you do number 3, I now want to leave you in the option. You now know how to do it with the calculator, and you now know how to do it without the calculator, correct? So I want you to have the option to do it with the calculator, without the calculator. Just to refresh your memory on how to do it without a calculator, I'm going to do number 2 without a calculator. So number 2 without a calculator would look like 1.6x minus 2.2 is less than or equal to 4.8x plus 7.4. So what I need to do is I need to get all my variables that have an x on one side and all my variables that do not have an x on the other side.
So you add 2.2.
I'm going to subtract my smallest x value, which is 1.6x. What I do to one side, I have to do to the, and I make sure I keep like terms together. All right, so let's evaluate. This goes away. This becomes -9.6 is less than or equal to, this went away, to
3.2x.
What's the next step?
Divide by 3.2. And you get 3.
And I get -3 is less than or equal to x, which is the same thing as saying x is greater than or equal to -3.
Oh, that's way easy.
All right, so you have 2 options. Number 3, I want you to solve it which way you're more comfortable with. We've now, Now we've learned it algebraically and we learned it graphically. So how you want to do it is now in your hands. All right. So for your homework, you either can do it this way or you can use a graphing calculator.
You can take that one?
I don't have one of them.
Okay. So,
Yeah, I don't think-
any questions? None? Are we good?
Yeah.
All right, tomorrow at the start of class, we're going to have to go over, we're just going to cover some basic inequality rules and just making sure you understand inequalities. We're going to summarize our inequalities, all the stuff we should know about inequalities. Yes. And you will not have homework over the weekend, so we'll come in, do this, and that will be it. And then a little more inequality practice with real world problems on Monday. Woo! I know you're excited. You don't have to show me your excitement. But be ready for that. All right? Thank you, guys.